Good evening. Welcome to the QCIS channel. Well, on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening, I'm going to talk about some emerging disciplines of engineering. Now, here on the QCIS channel, a lot of the information that I deliver comes from one of the oldest branches, and that's civil engineering. And when many of us talk about the engineering discipline, we talk about the popular disciplines that are offered in college. And basically, there's three, maybe four. Now, as you know, engineering comes from a few different arenas. It comes from, of course, mathematics, physics, chemistry, biology. And tonight, I'm going to feature some disciplines that you should be aware of because they're coming into play. And they're also going to affect how technology is run. Of course, what you have to understand about the field of engineering, that there's some fields that work with the public, the government, and you have to have a license. And that includes civil engineering, mechanical engineering, architectural engineering. And like I said, the popular branches of engineering that are in most schools are civil engineering, mechanical engineering, electrical engineering, chemical engineering. Now, something that you need to know within those branches of engineering, there are also sub-disciplines of engineering, those branches. Like, let me give you some examples so you'll know exactly what I'm talking about. I'll take civil. Well, civil engineering is its own field. But within civil engineering, you have construction engineering, environmental engineering, water resources engineering, transportation engineering, construction engineering, structural engineering. And you can include surveying engineering as well, because a lot of surveyors are now gathering data and are downloading it into computers where civil engineers can use the points that the surveyors gather for mapping. You have GIS, GPS, and then for electrical engineering, you have power engineering, energy engineering. Chemical, you get into petroleum engineering. Now, one thing I can tell you that is distinctive about environmental engineering, although environmental engineering, you could look at it this way. There are parts of it that are with civil engineering, and there are also parts of it that are with chemical engineering. So you have a lot of engineering branches that are breakoffs, like one that I didn't mention and I'll mention right now. You have industrial engineering. Now, most people don't even know what industrial engineering is. Well, when you deal with industrial engineering, you're basically dealing with the system as a whole. How can you reduce waste? How can you effectively manage a workforce? And when I'm talking about managing a workforce, well, with industrial engineering and, of course, engineering management, there's ergonomics, there's environmental health and safety. One big aspect of industrial engineering, there is statistical process control. And I took a class at Purdue University, and it was pretty tough because the information that we had to gather We had to put it on Excel. And I wasn't an Excel guru until after I took that class. Now I'm a lot better at it. And that's one thing you need to know when it comes to engineering. You need to understand the tools. Most people think it's just computer aided drafting. You need to know how to use the tools like Excel, Word Perfect. You need to be a good speaker. You need to be licensed. So without any further ado, let's go on to some emerging fields of engineering. And these are, now I found this on learnbots.com, and I'll keep the link to this presentation under my videos in the comment section. And I will say this, when it comes to the engineering industry, and that comprises of every branch of engineering and engineering technology, it is one of the largest and most important industries that has ever existed. Why? Because with new inventions every day, it's hard to keep up with the latest technologies, and there are dozens of emerging fields in engineering that may not be well known as of yet, but they will soon make their way into the market as they grow more sophisticated over time. So, as I stated before, we deal with technology. So, as technology continues to improve, the future of engineering is going to change as well. In fact, some engineers are already working on emerging fields that will make our lives easier and futuristic. Now, the best part is that you can enter some of these fields with a bachelor's degree in engineering. Now, again, this presentation, I'm just going to discuss 12 emerging fields for the future, and that includes robotics, biomedical, and cybersecurity, amongst others. And I'll give you the name of some schools. It's funny here, I'm in Indiana, and the big guru when it comes to engineering is Purdue University. Now, Indiana University, which is another Big Ten school, main campus is in Bloomington, Indiana. They are actually coming out with cybersecurity and IT engineering, and they want to get on the ball with engineering. Now, I will tell you, when it comes to a lot of colleges, engineering is a very expensive field to run, particularly mechanical and civil. Now, when it comes to electrical engineering, and there are different polytechnic sites at Purdue University where they run electrical engineering, industrial engineering, and of course, mechanical engineering. And I don't run construction or civil because they're more expensive to run. Why? Because you can reuse equipment over and over and over and over again, and you can easily create different branches of engineering by using electrical, industrial, and mechanical. For instance, mechatronics. But one branch, and I know my school, Temple University, my first school that I graduated from, and we talk about bioengineering. Now, bio, what does that come from? Anything that deals with biology deals with life. Bio comes from life. So, what is bioengineering? Well, basically, you can look at it this way. Bioengineers are ones that work with medicine. Bioengineers work on new technologies, and what they do is they combine science with medicine to create new ways for people who are injured or they even have illnesses. So if you want to become a bioengineer, you're going to need a bachelor's degree in engineering and maybe a master's degree in bioengineering. Now, what would be the best bachelor's degree? Let's say your school doesn't offer bioengineering. I would say go chemical engineering. And for the bachelor's, And then you can get into bioengineering for a master's, or you can go into industrial engineering. Industrial engineering, because you have operations, statistics, but let's leave industrial engineering alone for a moment. Let me substitute that with mechanical engineering. Because you think about it, mechanical engineering goes well with bioengineering, also goes well with chemical engineering. You see, a lot of what mechanicals do, and mechanical happens to be one of the, if not the broadest branch out there. It's the most popular branch in school, in any school. Most people, it's very hard to get into mechanical and even mechanical engineering technology programs. So for the most part, your undergraduate, before you get into bioengineering, bioengineering actually comes from chemical and mechanical engineering, and you may want to play with a little electrical engineering. Now, going back to industrial engineering, you might want to throw a little bit of that in there as well because of the ergonomics. You're dealing with humans. You're dealing with operations, linear programming. So that's where your industrial engineering would work. Now, a bioengineering example, NASA, my dad used to work for NASA, is developing new ways. Again, NASA, this is just a bioengineering example, is developing new ways to help fight diseases like cancer, diabetes, and heart disease. NASA bioengineers are working with engineers from other fields. Again, NASA bioengineers are working with engineers from other fields like chemistry and medicine, basically to create new tools that can improve patient care. The tools they're creating include a tiny device that can make a diagnosis in a matter of hours instead of weeks. That's, yes, a tiny device. What is it, a microchip? So it can make a diagnosis in a matter of hours. And this is how advanced technology is. Now, the future of bioengineers is as follows. As technology develops, bioengineers will continue to improve how humans can fight certain diseases. So being a bioengineer will be an exciting career because there are so many opportunities to discover new things that could help people live longer and healthier lives. And you know, with bioengineering, and my next topic, I'm going to talk about biomedical engineering. Well, if they do have bachelor's programs and you do well, you may be able to get into medical school, be a doctor. Yeah, they have engineers in some strange places, like teachers. Again, bioengineering is going to be a fantastic field. Now, you don't see civil in here, and I'll tell you why. And I like civil, but I'm going to say this. Civil is not as technologically advanced as other fields. In fact, it's one of the lowest paid branches out there. Why? Because with civil, you basically work on a lot of public projects, some private projects. You don't do a lot of prototypes with civil like you would in mechanical or electrical. Civil architecture, they utilize infrastructure. But getting back to biomedical engineering, they work with instrumentation systems. They work with biomedical technologies to improve healthcare for people who are ill or injured. So a bachelor's degree in engineering is generally enough to get you started on the right track to becoming a biomedical engineer. But some schools offer an undergraduate field of study, so you may have a choice on which type of engineering that you want to study. You probably need an internship or apprenticeship to get your foot in the door and land your first full-time job. Now, Purdue University at Indianapolis, they used to have a biomedical engineering technology program. I believe they still have a biomedical engineering program you can get into as well. And that's up and coming field. Now, again, this is a break off of biology, chemistry. Now, an example of biochemical engineering is how do you develop new equipment that could help surgeons perform better during an operation? That's what biomedical engineers at Texas A&M University, they're working right now to figure that out. And what they're doing is using computer modeling to design tools for surgery like artificial blood vessels and tiny organ motors. So future biomedical engineers right now are making a progress on new technology that could one day lead to the creation of, can you believe that, artificial blood vessels, which would help people who have cancer or heart disease. And this is why people are going to begin living longer. And they're also studying how to make better prosthetic limbs, which will become more important as wounded soldiers return from war. Interesting field to get into. Chemical engineering. Chemical engineers are engineers who use chemistry to solve problems. They could help companies develop new products or be researchers who create things like biofuels and food coloring. Industry leaders say chemical engineering is the top job in the US. So you definitely need a bachelor's degree in engineering if you want to try a hand at chemical engineering. Now, an example, GE is using chemical engineers to create energy efficient lighting. For example, they have to come up with a new type of light bulb that emits more light while using less energy. Chemical engineers are also working on creating fuel cells that use hydrogen instead of gas in order to power vehicles. So the future of chemical engineers looks like this. It's going to be dependent on the emergent energy needs that will need to be met. As our planet's population increases, so does its demand for certain resources like food, water, and energy. Engineers are working to make that happen, and they're doing it today. Now, one field that I just talked about, you wouldn't believe it, industrial engineering. Now, I would say that is probably the number 5 branch of engineering that colleges have. What industrial engineers do, they work to improve the way things are made and the machines that make them, that produce product. So they might study a company's workflow or improve their assembly line so it makes more products faster. So a bachelor's degree in engineering is enough to get you started, but certification like a green belt or Six Sigma from a professional organization can help advance your career even further. Now, here's an example of industrial engineering. NASA is using industrial engineers to create new tools that use 3D printing. They have developed a printer that can lay down thin layers of plastic, metal, or other materials instead of ink, so the machine builds up an object from scratch. The objects they're making include parts for satellites and even a wrench. So the future of industrial engineers looks like this. We'll need to focus on helping companies use technology better because of the increasing demand for new products and rapid turnover. There is a greater need for industrial engineers to help companies turn out products faster without wasting any resources or time. The key, rapid turnover. Think about that. And according to the Occupational Studies Handbook, future is bright for industrial engineers. But again, a number of people don't know what industrial engineering is. Well, back to one of my videos I did a year ago, and I explained what industrial engineering is. So moving on, robotics engineering. Now, robotics engineering is one that, again, Purdue has an engineering branch called robotics engineering. Where does that come from? Well, robotics engineering, manufacturing engineering, electromechanical engineering all comes from electromechanical and, of course, IT. Now, robotics engineers basically design and build robots that do certain jobs. For example, they could create a robot that plays chess or one that helps people with disabilities live more independent lives. You'll need at least a bachelor's degree in engineering, of course, to get it started, but different schools offer programs specific to robotics engineering. So you may have some choices of where to study if you want to specialize in this field. Here in Indiana, the best schools that you are going to get some robotics engineering or automation engineering or manufacturing engineering, Indiana State University, Trine University, and of course, Purdue University. It's where you're going to find those fields of robotics engineering. And an example, NASA is using robotics engineers to design tools that could one day explore other planets. They have built special robots that can dig into the surface of Mars and gather samples without any human intervention. These same kinds of robots could be used on Earth to create buildings or roads where humans couldn't survive. So the future of robotics engineers, it's like this. Basically, they're tied with the automation industry. So as companies try to find ways to cut costs and increase their productivity, they turn to technology like robots to help them do these things. So some jobs will require even less human involvement. So many people believe that the future of robotic engineering lies with creating completely autonomous robots that can replace humans entirely. And I believe in Japan, there's some experiments at hotels where there are no front desk clerks and robots are actually doing the check-in and check-out work in some McDonald's as well. So individuals clapping that robots are going to keep you from working, well, after a while, you won't have a job. And robots, they can program them to do them better than humans and much more efficient and faster than humans. So one that's emerging, it's brand new. And I actually talk about it with my scam series. There's a lot of criminal behavior that's taking place on computers. So cybersecurity engineering. And basically, cybersecurity engineers work to protect important information and computers from hackers and data thieves. So, bachelor's degree is enough to land you an entry job, but you can always go back for a master's degree or even a PhD. So, if your career interests speak to it, many employers, especially those within the government, are looking for candidates with formal training in cybersecurity. Now, an example. What happens when a stacker what happens when hackers, that's not stackers, that's hackers. What happens if hackers steal your credit card information? Well, cybersecurity engineers at Wells Fargo make sure that won't happen by creating new ways to protect the bank's data systems. So they examine software and hardware solutions to make sure cyber criminals can't get into the bank's private data. Engineers also look for vulnerabilities in their systems and try to fix them before they're exploited by thieves. Now, the future of cybersecurity engineers. And my dad and I were just talking about this this past Saturday. And there's another branch that's coming up that I'm familiar with. But let me get to the future of cybersecurity engineers. As information becomes more important, cybersecurity engineers will be in high demand. They'll work to protect everything from individual computers and mobile devices to bank databases and national infrastructure. The companies are looking for employees with formal degree programs or certifications. Moving on. Remember earlier I talked about chemical engineering? This is environmental engineering. In fact, as you know, this is the FE. This is what goes with environmental engineering for your license. Well, environmental engineering, it's an important type of engineering that can help improve air pollution, create new sources of energy, or make sure our water supply doesn't get contaminated. So you'll need at least a bachelor's degree in engineering for this field, but you can go on and get a master's degree or PhD if your career interests call for it. Now, an environmental engineering example is engineers at GE are using environmental engineering to create energy efficient ways of making fertilizer. They hope their efforts will help farmers produce the food needed to feed a growing global population without hurting the environment. The solution they design is basically a pipeline that sucks carbon dioxide out of the air and uses it to make fertilizer for crops while capturing any methane produced as a byproduct so it can be burned into energy. So, the future of environmental engineers. Environmental engineers will always be needed to design systems that help the environment without hurting people. So, the shift toward renewable energy sources like solar and wind will create new opportunities. So, as engineers design ways to reduce our carbon footprint, the demand for their services will increase along with it. So, again, environmental engineers have found new ways, design ways to reduce our carbon footprint. Now, another break off, it's another discipline, it's petroleum engineering. Penn State has a petroleum engineering curriculum or oil and gas engineering curriculum as well. I'd say petroleum engineering is a break off of chemical engineering. And what petroleum engineers do is they design and supervise oil wells, pipelines, refineries, or other equipment used in the exploration of oil. They usually need at least a bachelor's degree to get them started, but you may be able to enter this field with an associate's degree. Why? Because there aren't a lot of people in petroleum energy. In fact, if you really want to do some petroleum, the best state to do that in is in Texas. It may be Louisiana because they're along the Gulf Coast. So in this field, you can expect strong competition for jobs since petroleum energy, I call it petroleum energy, it's really petroleum engineering, which does produce energy as well. But the reason why the competition for the jobs is going to be fierce because petroleum engineering is one of the highest paid engineering fields. But I don't see a lot of people going down to Texas and Louisiana for these jobs. The curriculum is very tough, and number of people, the reason why these fields are emerging, they're some of the toughest fields to get in because you have to deal with circuits, robotics, machines, you have to deal with linear programming. It's a lot more technology that you have to utilize, and the courses are tougher. That's why you don't see curriculums like civil on this list. But you're dealing with high technology fields on this list, and petroleum engineering is one. And an example of petroleum engineering, if you like working outdoors and don't mind the idea of traveling around to different sites, petroleum engineering could be a good choice for you. Shell is using petroleum engineers to design tools that will help them drill for oil in an environmentally friendly way. The engineers are creating computer models of the underground rock formations they will be working with so they can find the best places to drill. And this is where you can also deal with fracking. Of course, this administration didn't want fracking, but you need energy. You want to be self sufficient, keeps gas prices down. And the future of petroleum engineers what are always needed to find new sources of oil, and they design equipment used in the exploration process. So oil companies are especially interested in hiring engineers with programming and data analysis skills since they're using more advanced software these days. Now, another field, Purdue University has this one. Well, they call it motorsports engineering. Indiana State University has a program. It's called automotive engineering technology. And there's an overlap between engineering and engineering technology. Engineering is more the theoretical approach, while engineering technology is more of the applications or applied because you have a lot more labs and it's less theory. And I'll get into that at a later time. But when we deal with automotive engineering or automobile engineering, what automobiles what automobiles are looking like today, they want more and more computerized and safe automobiles on electric cars. Well, automobile engineers design, develop, and test automobiles. They create plans that help companies decide how to manufacture each part of a car. Depending on the company you work for, your job may also include supervising production or helping out with other tasks like marketing or advertising. So, in this field, you're definitely going to need a bachelor's degree in engineering to get started, but you can expect strong competition for jobs. Now, here in Indiana, the way to get into automotive engineering, Purdue University, they have it's a break off of mechanical engineering, just like HVAC is also a break off of mechanical engineering. Well, they have motorsports engineering, and that is here in Indiana because of the Indianapolis 500. Now, you also have an associate's degree that you can get from Ivy Tech and automobile technology, and you can transfer that to Indiana State and get you it's a 2+2 program. Get you a degree in what we call automotive engineering technology, where you will have the fun of really working on cars to see how they actually work. And you'll be doing design as well. Now, an example of automobile engineering is engineers at Toyota are using automobile engineering to develop the next generation of electric cars and trucks. They're helping to make sure their vehicles produce as little pollution as possible and still run on the road. So some of these engineers came up with a special way of making the car's lithium ion batteries more powerful and reliable. So we're dealing with lithium ion batteries. And that is one of the most expensive parts of an electric car, the battery. So they want to make them a little bit more reliable, probably bring the cost down as well. Because the future of automotive engineers or the future of automobile engineers, there will always be needed to design new cars and trucks for the road. The rise in demand for, again, I just mentioned it, electric vehicles may create even more opportunities in the field since engineers will have to figure out ways of building these cars so they don't run out of power too quickly. Now, all that is going to stem into my dad's industry, electrical or electronics engineering. Now, this type of engineer designs electronic equipment, including computers, communications equipment, and medical devices. So you're going to need strong math skills for this field because engineers use a lot of equations like Laplace transforms, which is part of differential equations. They're going to use those fields to design new products. Now, I'm not going to be politically correct because they put STEAM in this. It's STEM. The A is for the arts. You don't need arts. Arts, if you want arts, go over there to the architecture field or the urban planning field. But STEM is on this channel. And I know this article mentions STEAM. Well, they put that in there to try to get more women into the engineering fields. No, you either have it or you don't. I'll be honest with you. Well, it's a good idea to take some STEM classes in high school because this field requires a lot of lab work. You'll need at least a bachelor's degree in engineering to get started. So, with electrical and electronics engineering, you can go on to earn a master's or a PhD if you're interested in doing it. I wouldn't because you're going to, as long as you get the experience, you're going to do well even with a bachelor's degree in electrical electronics engineering. An example, engineers at Johnson Controls are using electrical and electronics engineering to build new computerized systems for the steering wheel in your car. These systems are designed to help you park or drive more safely by changing how much power is sent to each wheel on a vehicle, depending on what's happening with the road. So these engineers are created, they also created a special algorithm that helps these products predict when they might need to take action in order to give drivers more control. This is when they're having cars that can park themselves, drive themselves. In the future, electrical engineers are always going to be needed to design new types of equipment that use electrical power. Since this field also covers communications and medical devices. So again, when I said electrical, you see a lot of these engineering disciplines are related. It goes back to biomedical engineering and bioengineering, medical devices. Well, again, electrical engineering, they use communications and medical devices, and job opportunities should continue to grow as people demand more sophisticated electronic devices. Yes, there is a demand for more sophisticated electronic devices. Now, electronics engineer or electronics engineering examples are as follows. Engineers at IDEO are using electronics engineers to help companies like Google create handheld computing devices for their employees. They design and manufacture custom equipment like computer servers, chipsets, and circuit boards for their clients. So the future, electronics engineers will always be needed to create new types of equipment that use electrical power. Some work with communications devices or medical equipment, which means the field is expected to grow as society becomes more reliant on these technologies. And again, aeronautic engineering also comes from mechanical engineering with a little bit of electrical engineering. Well, there is a program, University of Maryland, they have aeronautical engineering because of NASA. Well, Purdue also has aeronautical engineering and aeronautical engineering technology. Basically, aeronautical engineers design and they develop aircraft and spacecraft. They start by coming up with a basic design for the vehicle and then work to create a strong, lightweight frame that's capable of keeping everything in place while it's flying through the air or zooming through space at thousands of miles per hour. So you're going to need a lot of math and science skills for this job since aeronautical engineering uses a lot of equations to help design new vehicles. You will also need a lot of lab work experience. It says some, but you're going to need a lot of lab work because you got to make that design work, that prototype. And you're going to need the lab work to test out your designs and see how they function in a real world. So most employers expect applicants with at least a bachelor's degree in engineering, although you can go on to earn an advanced degree if your career interest calls for it. So, an example of aeronautic engineering. Engineers at Airbus are using aeronautic engineering to build new aircraft that are lighter and more fuel efficient than the past models. So they've come up with a way of replacing aluminum sheathing with carbon fiber in order to reduce the weight of each plane, which also reduces the amount of fuel needed to power it. So the future of aeronautic engineers will always be needed to design new types of aircraft and spacecraft. Since this field uses a lot of math and science, the opportunities should continue to grow as society develops more advanced technology. And solar energy comes from solar engineering, which you could also say chemical, mechanical, little electrical, and a little environmental. And solar engineering, some Purdue University before they end their relationship with Indiana University, right now has a degree in energy engineering. They also have a degree in energy engineering technology at Purdue University. But solar engineering is part of energy engineering, which is comes from which basically comes from mechanical, electrical, and once I sum it up, I'm going to give you my insight on all these branches on why they're emerging. But solar engineering is the design and construction of infrastructure that uses solar energy to provide light or space heating, cooling, and other beneficial functions. The term also applies to the employment of such infrastructure for electrical power or electric power. So solar engineers research, develop, plan, and strategize how to implement solar power applications. So solar engineering examples, as the development of solar cells has been greatly improved, many people start to look at them as a source of alternative energy. This has resulted in a booming solar energy industry, which is expected to reach 5.7 billion. Now, this was by 2013. Well, it's probably more than that. Now we're in 2024. So basically, solar cells are able to create and absorb sunlight and solar energy, which can be used for different practical applications. So some of these include heating, water, and solar thermal systems, heating space with a solar furnace, generating electricity by photovoltaic PV cells, and providing light through the use of LEDs, which that's a light emitting diode. And the future of solar engineers. Job of a solar engineer can be quite challenging because it's a new and fast growing field, but the compensation is also very good. In fact, a solar engineer can have a starting salary that is almost double the national average of $42,000. Now, as I conclude, the future of engineering is bright and full of possibilities. Engineers have a wide variety of opportunities from building bridges to designing spaceships. So it may take some time before you know which one sparks your interest, but you got to keep exploring. Engineering has never been more exciting than now, with new fields emerging all the time. So you have to be able to pick up skills quickly thanks to online courses or enrolling in an undergraduate program at your local university. Just don't forget about your internships. And good luck if you're going into the field of engineering. Now, I want to say this, give you my commentary. If you look at all the branches that I talked about tonight, they all stem from chemical, electrical, and of course, computer science. Why wasn't civil included? Well, again, the other branches, they focus highly on technology, where civil architecture, architectural engineering, or building engineering, they all reside on infrastructure. You need infrastructure, but the technology is improving all the time. Some of this technology, you can't outsource it. Some of it you can. But at the bottom line, biomedical engineering, bioengineering, solar engineering, robotic engineering, electronic engineering, cybersecurity engineering, they're basically, and automotive engineering, they actually basically come from, again, three of the main fields of engineering. That's chemical, electrical, and mechanical. And I believe industrial also comes from mechanical. In fact, you had back in the 1950s, Purdue, I believe they had a husband and wife team that taught mechanical at Purdue. Penn State was one of the first schools to teach industrial engineering. But overall, those are the 12 emerging fields of engineering, and that concludes this topic on the new emerging disciplines of engineering. If you like what I just presented, please comment, share, and subscribe. And if you are looking for some political, social content, check out my main channel, the 411 Talk Zone radio show channel. Videos on that channel every Wednesday, working with the scam series right now. Now, once I record videos on YouTube, I also upload them to my Twitter page. So you'll find both my channels, the 411 Talk Zone radio show and the QCIS channel on my Twitter page. Now, since the QCIS channel is an educational channel, you're also going to find that channel on my LinkedIn page. And once again, thank you for listening and viewing this content about new emerging engineering disciplines from the QCIS channel. And on this channel, get a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.